Ladies and gentlemen, please give your attention to a documentary on the discovery of the DNA double helix.
When the story began, Jim Watson was an awkward 23-year-old from Chicago. Francis Crick was an extrovert 35-year-old physicist, mainly on magnetic mines. In the early 1940s, the scientists at Cold Spring Harbor were convinced that the information in the gene was chemical. Oswald Avery, working at the Rockefeller Institute in New York in 1944, identified that chemical. Avery wasn't even sure he believed it himself. Deoxyribonucleic acid, shortened to DNA. In 1951, there was a meeting on X-ray crystallography in Naples, and Watson decided to go to Naples.
Morris Wilkins, and he showed an X-ray photograph of DNA, and I suddenly became aware there existed someone who actually was trying to solve the structure. I tried to talk to him, but Morris doesn't talk much to strangers.
After some trouble, Watson joined a group headed by Sir Lawrence Bragg at the Cavendish Laboratory in Cambridge. Linus Pauling, Nobel Prize winner twice over, had more than anyone led a generation of scientists to think of molecules. Pauling found a way to turn the molecule into a three-dimensional structure, a structure that made sense, a helix, a spiral, whose dimensions fitted perfectly with a few experimental factors.
Because Rosalind Franklin was a professional crystallographer.
At that time, Franklin knew more about the structure of DNA than anyone else. But in November 1951, when Rosalind Franklin gave a talk on her latest results in X-ray crystallography, it wasn't Crick, it was Watson who went to hear her. And this was a big mistake. Watson had not yet learned the jargon of crystallography. And from the misunderstanding of Rosalind Franklin's talk in November of 1951, Watson decided that it must be a triple helix with the three strands in the center and the different bases sticking out at right angles. Frank took an X-ray photo. The X-ray photos showed that the structure of DNA was perfectly regular. But the big question was whether the structure of the molecule would tell you anything about how it worked, about how it replicated itself, and Crick in particular began to wonder if the bases might hold the answer.
A rather curious thing happened when a brilliant young theoretical chemist called John Griffith, and he thought that adenine would attract thymine and that guanine would attack cytosine. And I said to him immediately, well, that's all we need.
If you always had the A and the T together, then the quantity of A and the quantity of T in any DNA molecule must be the same. And the same with the other. The quantity of G and the quantity of C must always be the same. This was already known experimental fact. Erwin Chargaff, an expert in DNA structure, had analyzed DNA from a number of different organisms and had come across with one ironclad rule. Watson saw the X-ray diffraction pattern of the B form of DNA, but which he'd put aside while continuing to work on the A form. This cross-like pattern of reflections was exactly what you would expect of a helix.
I started putting the phosphates in the center. Francis told me, why don't I try putting the phosphates on the outside?
And from then on, we began to think about putting the phosphates on the outside, which meant the bases had to be on the inside.
It wasn't until the following morning I came in and I started to put them together in pairs, because this stage we decided, well, two-chain structure is simpler than three-chain. But even more important, Francis, by using these rules, A and T and G and C, we understood how the molecule replicated.
That's right. Everything from then was clear. Everything was finished except the hard work, namely the model building.
And this is how the base pairs can be fit together to form the double helix. Watson and Crick wrote the structure of DNA in Nature. It appeared in the April 25, 1953 issue of that and was followed by two papers, one by Wilkins and one by Franklin. The Watson-Crick paper itself, in which the picture of the double helix appears for the first time, specific pairing immediately suggests a possible copying mechanism for the genetic material. Watson and Crick decided the order of authorship of their paper by tossing a coin.